Today we're going to have a look at this PCB that came out of a fridge. The fridge is only, I think it's maybe 3 years old, and the problem was that when the door was open in the fridge, the LED lights that are in the fridge would flicker and the lights in the fridge wouldn't stay steadily on. And eventually the lights gave up altogether, so I took this out of the fridge and then went to inspect it and realised that this unit is a kind of I'd say it's a classic example of kind of planned obsolescence, where you used to have these old style fridge bulbs that you could just screw it in and out of the socket and very easily replace the bulb. But when this unit goes dead, if you look these up on the manufacturer's website, I think they're maybe like £30 or around that delivered. So they're substantially more expensive than the old replacement LED bulb would have been. So as you can see, we've got 3 LEDs in this board here, and it's relatively straightforward in that it doesn't have a lot of components on it. I've done a wee breakdown of, just get a pointer here. So I've done a bit of a breakdown of what the components are. So the LEDs are labelled up LED 1, 2 and 3. You have this bridge rectifier here, which takes in AC and then puts it out as DC. So the DC side is here, AC on this side. You have various resistors, all labelled up here. And then you also have this Zener diode here on the back, in the front as well. And I think that's just to be used as a voltage regulator in this particular setup. So Big Clive has a good video on something similar to this kind of board. It's not exactly the same, but it's relatively similar. So if you want to see more about the electronics and how this works, it's probably best to maybe look at his video as well. But you'll see here on the back, you've got 2 big capacitors here. You've got this, I think these are called like safety capacitors. And then this is just a standard electrolytic smoothing capacitor on the DC side then. So the rectified DC is put through this to try and flatten out the signal. So normally I would bin this type of stuff and just replace it, but in this case, because it's such a simple, relatively simple board, I thought we could do a bit of diagnosis on it. So the first thing that I did do was I put a test meter, or a multimeter, across both of these capacitors. This one tested out fine, came up to the rated value. I think it measured just under the rated value. This one I couldn't get any value out of it at all, and stupidly then thought that this was the component that needed replacing. But I realised then afterwards that the rating on this it's actually a 50 volt. I think it's 470 microfarads. Can't see it, but I think it's around 470 or so. Stupidly thought that was a component that needed replacing. Replaced it because they're just cheap on eBay to save me any more probing. Replaced it, and the unit was still broken. So, lesson to be learned from that was that these capacitors here are difficult to test using a standard multimeter because of the voltage rating. But when I then put it across an ohm meter, so when I checked the resistance gradually went up and spiked, which is an indication that the capacitor was working okay. The original one, I should say. So I did a little bit more diagnosis then, and came up with this circuit diagram. So this is just a rough circuit diagram to explain what's going on. You have that safety capacitor and a resistor across it, which is the R1 resistor, which is this one here. That's the one that bridges the capacitor there, safety capacitor. Then goes through the bridge rectifier, which is this part here, converts from AC on the bottom to DC out on the top. You have the smoothing capacitor here on the back, which is this guy here. And then it goes in parallel with those, you have resistor 4 and the Zener diode. And then you have the LEDs, which seem to be in series. But and along with them, you have these 2 resistors in parallel. So the 2 resistors in parallel are R5 and R6 here. So when I did a bit of testing then, what I found was that I probed across each of the LEDs with a multimeter to try and figure out what was going on. And it looked like we were getting quite a high voltage across this particular LED here, which is LED 1. So we were able to get, I think it was around 14 volts across here. And then as we probed across LED 2 and 3, you could see that there was no, the voltage had dropped off hugely at these two LEDs here, so it was more like 4 or 5 volts. So that prompted me then to consider that there was something weird going on here in this part of the circuit because of the big difference in voltage between here and here and here and here. So I then probed across here and shorted this out, and lo and behold the light came on. So I'll just switch that now. I'll just show you that in action. Okay, so I've got my multimeter set up here in the current setting. So in terms of probes here, so I've set them up with common and to the amps rating. And I'm putting the dial around to the amp setting. So this is effectively like putting in a short into a circuit. So just think of these probes as being connected with an amp meter in the middle, and you're just creating a short for the electrical path. So this is the LED that was running at very high voltage, but the others weren't, but it wasn't lighting up. So I discovered then that when you short this LED like this, the rest of the LEDs come on. So at that point we had identified that this LED is actually the source of the problem. So one little chip in this array here is going to cause the rest of the LEDs not to light effectively if that is broken. So the first thing we're going to do, we're going to try and just reflow the solder that's on that LED, and then if that doesn't work, I think we're going to either try and replace it, or else we'll just bridge that LED completely with a piece of wire. I think it's going to be the easiest option. Of course, when I'm testing this, I have it hooked into AC power. So if you're going to do this, be extremely careful about having a board running live. It's very, very dangerous to have. The only thing that you should be using to contact the board at all is a set of insulated multimeter tips like this. And anytime you walk away from the board, just switch it off. So I've done our troubleshooting now. Let's have a go at reflowing the solder on that LED and see if it works or not. And if not, we'll probably just bypass it, as I've said. Right, so first up, we'll just try doing a wee reflow of the solder next door to the chip here. So we'll just get a little bit of flux. Obviously, we have the power turned off. We just have our soldering iron plugged in and heating up here. So we'll add just a tiny bit of flux, try and get it in tight against that leg on the LED. Okay. And we've got our soldering iron here. So this iron, the tip that I'm using here is a lot bigger than I would want to be using, but the other tip is burnt out on this one, so I actually have to buy a new tip for my iron. So we'll just get our iron in there. We'll do one leg at a time and attempt to reflow the solder. Okay, that's the solder redone. And we'll just clean the flux back off again, because flux is partially conductive. You always have to clean it off before you do power switch on. So we're still getting nothing there across the chip. Okay, so we've got some desoldering braid here, and we've just fanned it out a little bit to try and make more surface area on it. And we'll just add a tiny bit of flux to that braid as well. And let's just try and desolder this. I think this is going to be too tricky, so I think we're just going to have to bridge this LED with a piece of wire and use that as our fix because, well, a couple of reasons. The soldering iron that I have, the tip on it is far too wide to be able to do close soldering here, which means that and I do believe that there is a pad in behind there as well. So I don't think we're going to be able to get that off. So let's switch to using a piece of wire. So you can see here now I've just taken a leg from a new capacitor and used that as our new track to bridge across the LED. So I'm just going to wire in the that track now to bridge that. So let's do that. It's quite delicate, this type of work. I'll actually rotate the board around now so we can solder on the other side. Clean the tip of the iron a little bit just to make sure it's nice and hot. Okay, so that's the track soldered in. We'll let that cool and we'll check if it is going to work. Okay, so there we have it, guys. We have the track soldered in. It's definitely not the cleanest of jobs, but it's a repair that will do the trick. So as you can see now, when I switch it on at the mains, we're getting the other two LEDs lighting up. So this will keep the board running for another while. Obviously it's going to be running at 2/3 of its previous output. Ideally I would like to be able to replace that, but again, because I don't have the right setup, I am just going to bridge across that LED for now. As I've said, I measured the current that is going through these other two LEDs. It seems to be about 0.1 of an amp, which is totally fine. It's within the rating of these LEDs. So this will save us from having to bend this board for a while. So hopefully this video is useful to you guys. Hopefully it'll help you to repair your own boards if you're having these kinds of issues. And I think it's pretty crappy on behalf of manufacturers that they've started building LED bulbs into fridges like this instead of those old style replaceable ones. So if you like the video, please consider hitting the like and subscribe button, and you may want to check out my channel and some of my other videos as well. Catch you in the next video. Bye.